Here's let's talk about the continuity at a point. As we all know, that there are functions whose limits are not equal to the function value at x equals c, meaning limit of f of x as x approaches c is not equal to f of c. And in this section, we will be focusing on the continuity of a function at a specific point. What does continuity at a point means? Initiatively, this means that in drawing the paragraph of a function, the point in question will be traversed. Let's start by graphically illustrating what it means to be continuity at a point. Consider the graph that is being shown. In this function, f of x equals to 3x minus 1. Is it continuous at x equals 1? The answer is yes. And just looking at the graph, to check if the function is continuous at x equals 1, use the graph. As you can see, the 1 is able to travel the graph from the left side of the number x equals to 1 going to the right side of x equals to 1 without lifting one's pen. Therefore, we can say that the function is continuous at x equals 1. The simplest way to determine if it's continuous is if the line is tuloy-tuloy or continuous. For further knowledge, here's the second example. Consider the graph of the function g of x, 3x squared minus 4x plus 1 over x minus 1. Is the function continuous at graph x minus 1? The answer is no. If we follow the process from the previous example, tracing the graph from the left of x equals 1 going to the right of x equals 1, as you can see, there's a hole or gap in that line. This means the way the line had been put into is not continuous, creating a hole into the graph. Thus, the function is discontinuous at x equals 1. For the third example, consider the graph of function hx equals to 1 over x. In the graph below, is the function continuous at x equals 0? The answer is no. If we trace the graph from the f of x equals 0 going to the right of x equals 0, we can see that they are both have different direction to point to. The left of x equals 0, function values will go downward indefinitely, while at the right of x equals 0, the function values will go to the upward indefinitely. In other words, limit of a1 over x as x approaches 0 to the left is equal to negative infinity, and limit of 1 over x as x approaches 0 to the right is equals to positive infinity. Therefore, conclude the function is discontinuous at 0 as at x equals 0. If we summarize the whole idea, we can make a pattern to simply determine if the function is continuous at a point that was given. The first example you can simply tell is continuous if the point is shaded and in a straight line. The second example, you can simply tell it's discontinuous if the points have a hole in it. And the third example, you can simply tell it's discontinuous if the lines are colloquially to each other, as a curve that do not touch each other, or parallel lines, the lines which do not met. Moving on to example number 4, determine if f of x equals x cubed plus x squared minus 2 is continuous or not at x equals 1. In this example, they were not given a graph of a function, but the function itself. How do we determine the function is continuous at a given number? In this case, we have to check the three conditions. There are three conditions of continuity. A function f of x is said to be continuous at x equals c if the following three conditions are present. The first condition is f of c. The f of c must exist. The second condition, the limit of f of x as x approaches c must exist. And lastly, the last condition, f of c must be equal to limit of f of x as x approaches c. Let's try to the example number 1. If the function is f of x equals x cubed plus x squared minus 2. Let's find if it's continuous or not. Let's find if the f of c exists. If x is equals to 1, just substitute the number then f of 1 is equal to 0. So that means f of c exists. Let's now check the second condition. The limit of f of x as x approaches c. Substitute the number of limit of x cubed plus x squared minus 2 as x approaches number 1. Let's substitute the number. Turns out to be 1 cubed plus 1 squared minus 2. And the answer is 0. Therefore, the limit of f of x as x approaches c also exists. There's only one condition needed to determine if it's continuous or not. F of 1 equals 0 and limit of f of x cubed plus x squared minus 2 as x approaches 1 is also equals to 0. Therefore, the function is continuous. So that's it for our today's lessons. Hope you learned something. God bless us all.